Now, let's talk about exponent properties. There are some rules when it comes to exponent, and that's why we have to go over each rule in details with some examples so we have a clear and deep understanding of the meaning of exponents. Rule number 1. Rule number 1 is called rules of 1. Rule number 1 says any number raised to the power of 1 equals itself. Let's say we have 2 to the power of 1, it equals 2. A to the power of 1 equals A. M to the power of 1 equals N. That makes sense because the power shows how many times the base is multiplied by itself. If it's only multiplied one time, then it's logical that it equals to itself, right? Rule number 2 is called zero rule. According to the zero rule, any non-zero number raised to the power of 0 equals to 1. Let's say we have x raised to the power of 0, it equals 1. 5 to the power of 0 equals 1. Or let's say we have 3 to the power of 0 equals 1. Any number to the power of 0 is going to be 1. And then we have rule number 3, that is negative exponent. According to the negative exponent rule, any non-zero number raised to a negative power equals its reciprocal raised to the opposite positive power. Let's say we have 5 to the power of minus 3. That equals to 1 over 5 to the power of 3. Right? And then if you want to solve it, you would say 1 over 125. Or you have 2 to the power of minus 4. We put it in the denominator, 1 over 2 to the 4th power, and the result is 1 over 16. So you might ask two questions here. The first is why 2 or any number to the power of 0 equals 1? And the second question might be, what does a negative exponent mean? Let us work through a pattern and see the concept, how the concept developed. Let me clear the table first. Let's say we have 2 to the 5th power. Okay, so the result is 32. 2 to the 4th power is 16. 2 to the 3rd power is going to be 8. 2 to the 2nd power is 4. 2 to the 1st power is 2. 2 to the 0 power equals 1. Any number to the 0 power equals 1. So, question, what is happening here? There is a pattern here. At every step going down, you divide the number actually by 2. 32 is divided by 2 and the result is 16. 16 divided by 2 is 8. And so you take the pattern down, right? Now let's continue this pattern and divide it by 2. So 2, after 0 we go to minus number. 2 to the power of minus 1 is 1/2. 2 to the second power minus power is 1/4. 2 to the third negative number is 1/8. And if you continue that to the fourth negative number, you'll have 1/16. So you see the pattern here. That's why if you go down this pattern, you could see all of them divided by 2. So if we continue the pattern to the negative side, you could see we can have negative exponent in our pattern. Let's do one more example. Let's say we have 3 to the 5th power, which is 243, and then we have 3 to the 4th power, and it's going to be 81. 3 to the 3rd power is 27. 3 to the 2nd power is 9. 3 to the 1st power is 3. 3 to the 0 power, as we know, for all the positive whole numbers, when they are multiplied by 0, they are always 1. So we continue this pattern. So far, all of them are divided by 3. 243 divided by 3 is 81. 81 divided by 3 is 27. So again, pattern is going down. Let's continue our numbers to the negative. So 3 to the power of minus 1 is 1/3. 3 raised to the minus 2 is 1/9. 3 is raised to minus 3 is 1/27. What if we have a negative number? Instead of having, for instance, 2 to the minus 2, what if we have minus 2 to the power of 2? Okay, let me clear the table first, and then we can work through that problem. So if we have a negative base raised to a power either negative or positive, we follow the same principle as we did. Let's say we have minus 3 to the power of 3. It equals minus 27. Let's say we have minus 3 times minus 3 times minus 3, right? Negative and negative produce positive sign, but positive and negative, these two produce negative sign. So it's negative 27. Minus 3 to the 2nd power is positive 9. It is minus 3 times minus 3 is 9, right? Then minus 3 to first raised to the 1st power is going to be minus 3. Minus 3 to 0 power is 1. Now, each time, again, like the previous one, you could see that the pattern is every number is divided by 3, and it's going downward, right? Now we continue it to the negative side, and we write minus 3 to the power of minus 1. So in order to eliminate the negative power, as you know, we write the reciprocal of it. It will be 1 over minus 3. But since minus 3 doesn't have anything to multiply with, so it remains minus 3. Minus 3 raised to the negative 2, we write it as minus 3 to the second power, which will be 1 over 9. So minus 3 raised to the third and negative third is going to be 1 over 27, and the sign is going to be negative, same as we had in the positive section. Let's raise it to the fourth power. Minus 3 to the minus 4 is going to be 1 over minus 3 to the fourth power. Excuse me. Is going to be 1 over 81. So as you see, the pattern is dividing each number by 3 here. If we have a negative base, same rule is applied. The only difference is the signs that alternate every time that we have an odd or even number. Let me clear the board first and then continue with the rules of exponent. Now, rule number 4 is called product rule. The product rule of exponent says that when multiplying two powers that have the same base, you can add the exponent. Let's say you have 2 to the third power multiplied by 2 to the fourth power. The rule says in this case you can write the base and add the exponent together. You'll have 2 to the seventh power, which is 128. Or let's say you have 8 to the second power times 8 to the third power, and add 2 exponent, and you'll get 8 to the fifth power. It will be 32,786. Next is power rules. The power rule says to raise the power to a power, you just need to multiply the exponent. Let's say you have 2 raised to the third power and is raised to the second power. You can multiply 3 by 2 and have 2 to the sixth power, which is 64. Let's do another example. You have 4 raised to 6th power, and then together they are raised to 5th power. You write down the base and multiply the powers. 6 times 5, you have 4 raised to 30. So you have rule number 6, which is quotient rule. The quotient rule says that we can divide two powers with the same base by subtracting the quotient. Let's say you have 5 to the 5th power divided by 5 to the 3rd power. You write it 5 minus 3 is 5 to the second power. Let's go through the long way and see how it works. You have 5 times 5 times 5 times 5 times 5 divided by 5 times 5 times 5. It cancels out and you'll have 5 times 5 equal 25. 5 to the second power equals 25 2. So in order to divide two powers with the same base, you can write the base and subtract the exponent. Now, these are the properties of exponent. However, there are some common mistakes that you should be aware of. Let me clear the board first and I explain those common mistakes. So, there are some common mistakes people do when it comes to exponent. I'm going to put down the rules and the mistakes about it, and so it prevents you from making that mistake. Rule says x to the 0 power equals 1. For example, 4 to the 0 power equal 1. The mistake is people write it as x to the 0 equals x, or 4 to the 0 equal 4. That is a mistake. The second rule is about rules of 1. First power. It says x to the 1 power equals x. 5 to the first power equals 5. It is incorrect to write x to the first power equals 1 or 5 to the first power equal 1. That is incorrect. So the product rule says if we have two numbers with the same base, we can add the exponent. Let's say we have x to the m power times x to the n power. We can write it as x to the m plus n, right? Or let's say we have 3 to the second power times 3 to the first power. We can write it as 3 to the 2 plus 1 power, which is equals 27. The incorrect form that some people write is they multiply the power. They say x to the third power times x to the second power. They multiply it and write it as x to the 9 power. While the correct form is x to the third power times x to the third power equals x to the 3 plus 3 equals x to the 6th power. Let me clear the board here and continue with the rules and the common mistakes. So the quotient rule tells us that we can divide two powers with the same base by subtracting the exponent. Let's say we have x to the n power over x to the m power. You can write x n minus m power. Or let's do another example. 4 to the third power over 4 to the second power. We can write it as 4 3 minus 2 4 to the first power equals 4. So as for the quotient, you subtract the exponent. But the incorrect form is to divide the exponent instead of subtracting. Let's say we have 4x to the 6th power and 2x squared, and the incorrect form would be 2x to the 3rd. We divide 6 by 2. But the correct form is 4x to the 6 over 2x squared is 2x 6 minus 2, which is going to be 2x 4. We covered pretty much the basic of the exponent. While we are on that subject, I would like to talk about scientific notation. But first, let me clear the board.